Logarithmic equation. This is a well-known property of logarithms right here, m log, and the base here is not really important, you'll see. M log b means the very same thing, and this follows from the properties of exponents, is equal to log any base. This is base 10, I guess, technically, since we don't show it, but it's not important. B raised to the m. Okay. Alrighty, that's exactly what happened here. Our m is 2. We drag it around here. Now this works out nicely, and by the way, this is the sum to product property of logarithms. We have a sum here. Now it becomes a product. Very, very convenient property. It also follows from the laws of exponents. Now the log function is 1 to 1, and so what we get right here is that we can just write down the arguments here, or the respective, equate the input arguments. So we have x times x plus 10 times x plus 14 Now, the squaring of the square root gives us a constant term of 663 over here. Okay. Now, at this point, you may think, well, what do we have to do? Do we have to expand this out and try to solve a cubic equation? Answer is no, because we can write this as, this is divisible by 3 by the well-known trick. If the sum of the digits are divisible by 3, the entire number is divisible by 3. So we can anticipate that this is going to have a factor of 3. So we can write down 3 times 221. Okay, and then a little bit of work's required to show that this is equal to 3 times 13 times 17. It's a prime factorization. And something called the fundamental theorem of arithmetic assures us that any integer has a unique prime factorization. Now notice, this just cries out for the solution, right? Notice that x, if x is 3, well then 3 plus 10 is the 13 that you see right here. And then 3 plus 14 is the 17 you see right here. So we see clearly that x has to equal 3 just from the prime factorization. And that's the answer to the problem, folks. X equals 3. And y'all, really, we did this by using the sum to the product property and also this property of exponents, where the exponent this multiplier actually becomes a exponent. Now, it's not quite as easy. It sounds all tidy and everything, but you see there are other divisors here. For example, you could have written this also as 1 times 39 times 17, right? But there's no way you're going to get this to equate to this as far as integer solutions. Now, I think there's complex solutions, but I think this is the only real valued solution right here. I'm fairly certain. But you can see this particular factorization would not line up with this as far as integer solutions. And I don't think, I think there's 2 complex solutions, and this is the only real solution. All right, everybody. Hope you enjoy.